All right, so we're going to start chapter 3, section 3.1, functions, all things related to those. Lots of stuff in this section. So buckle up your, as the preacher says, buckle up your pew belts. It's a lot to cover here. So. All right, so the basis of functions are things called relations, and a relation is a correspondence between two sets. And any relation is just any two sets, but in algebra, we relate those two sets to be the domain and range. Domain, normally X, range, normally Y. Okay. You might also see it in terms of input and output. All those things are ways of relating domain and range. So when we talk about domain, normally we're going to be talking about X. For 98% of the time, we're going to be talking about the X values when we're talking about domain. There's a small percentage of time that when we talk about the inverse that it swaps. But domain are the X values. X values on a graph go which direction? Left and right. Y values go up and down. So when we talk about domain, we're talking about how much the function moves left to right. Talk about range, we're talking about how much the function moves up and down. Okay, so those are the things we're dealing with. An example of a relation, one of the easiest ways of looking at one, is just a set of ordered pairs. So like 3, -2, 5, 6, -7, +8. That is a relation. Okay, so that's an example of a relation. You got X values, you got Y values. The domain of that would be 3, 5, -7. The X values, the range would be the Y values, -2, 6, and +8. So we're talking about those things. That's what's going on. Now, when we get into the actual title of the section is functions. Functions are special types of relations. A function, and in college algebra, normally when we talk about a function, we're talking about from X to Y. So it's a function in terms of X. Basically, we get Y equals. In algebra class, the way we graphed a line was Y equals mx plus b. That was a function from X to Y. So X values generate Y values. That's what kind of functions we're dealing with in college algebra. And basically every algebra class you have in high school. Get into calculus and things. Sometimes you relate the other direction from Y to X or something like that, depending on what you're trying to do. But for all purposes, college algebra, it's going to be from X to Y. So what it does is it associates each X with one Y. Doesn't repeat X's. That's the layman's term for that. So never repeat X values. If you're a function, you don't repeat X's. Okay, that's the rule. Okay, so what we're going to do first is we're going to play the popular game is the relation a function. So it's a yes or no, and if it's a no, we need to tell why it's not. Okay, so first example. Example A is we got a set of ordered pairs, 2, 3, -3, 5, 6, 4, 8, -2. Is that a function? Why or why not? It's a set of ordered pairs. That's a relation.
Yes, because it has X and Y values and it's going from X to Y.
Okay, and that's true, but it also, what about the X values? They don't repeat, so that means it is a function. So all of those things are true. Yes, it relates X to Y. It's got X and Y values, but the X values don't repeat. So yes, this is a function. So example B. Another set of ordered pairs, -3, 7, 8, -1, -2, 7, 8, 0. There's a relation, set of ordered pairs. Is that a function? Why or why not?
But it's not because the X repeats.
What X repeats? 8. So we got a repeating X value of the 8 there, so it's not a function. Because X is repeated. Look at that. That 8 is the X repeated. Does the 7 being repeated, does that matter? No, not in whether or not it's a function. Later on, we'll talk about things called one-to-one functions, and one-to-one functions, then you can't, it's 1x to 1y, and it has to be 1-to-1. You can't repeat y's when it's a one-to-one function. So this is just a regular function. X's can't repeat. It's okay if y's repeat. But when we talk about one-to-one functions later on, there's rules about the y values for them. All right, so they're not always going to represent functions or relations in a set of ordered pairs. Sometimes they'll do what's called a mapping, and which is 2 bubbles. And they'll have some numbers in the bubbles. One bubble they'll label domain, and one they'll label range. And a mapping is just that. You're taking X values and mapping them to a Y value. So the 3 goes to the 6, and then the 5 goes to -2, and then 7 maybe also goes to 6. It's just another way of representing ordered pairs. So the ordered pair that comes from this 3, 6. This is the ordered pair 5, -2. This is the ordered pair 7, 6. So is this a function? Yes, because it does not repeat what? X values. It does repeat a Y value, but that's okay. That's not a problem. We're testing whether or not something is a function. Let's do another mapping. Three, -5, 8, 7, -9, 10. So we had 3 to 7, -5 to 10, 8 to -9, and then 3 also went to 10. Is that a function? No. Repeated X. So list of ordered pairs or set of ordered pairs, that's a relation. We can test whether or not it's a function just by looking at the X values. A mapping, same idea, is exactly the same thing, just the representation is a little bit different. Sometimes they can throw things at us. It might just be a graph. So I'm just sketching a graph here, just X, Y coordinate plane, and then this blue line, that's my relation. That blue line, what does it represent? Or the slanted one for anybody that's colorblind. Is there anybody colorblind in here? I prefer to colors a lot. And if it's all gray, I'll change what I do. So the slanted one there, what does that blue line represent? Ordered pairs. How many? An infinite number of them. We couldn't even count how many there are. Okay, because everywhere that there's a piece of blue ink, there's an ordered pair. Right? So all of those ordered pairs. So looking at it in list format, is that possible?
I mean, it could.
Yeah, but is it feasible? No, it's possible to do, but not really feasible to do. So testing that by the same way we've done the first 4 examples doesn't make sense. Does anybody know another test that we might could do in order to do this? The vertical line test, absolutely. Vertical line test, if we take a vertical line and place it anywhere on that graph, I'm placing several here to simulate taking a vertical line and going all the way across that. What are the rules for the vertical line test? It can't cross the line twice. If it does, what's that mean? Not a function, because what happens? Same x value more than once, okay? So this one passes the vertical line test. And, you know, we're just going to note that. That it passes the vertical line test, which means x's don't repeat. There's a relation. It's an ellipse. Shape that's called. Something like that. No, it's not really perfect, but it's pretty close. Being an ellipse, you can tell it's not a circle. Is that a function? No. Why not? And that vertical line hits it in two places. It's got the same x value, different y values. So that's definitely not a function. Fails the vertical line test, which in turn means x repeats. All right, so here we have a graph that failed the vertical line test. Well, they won't always give us the graph, and sometimes they'll give us an equation, maybe something like this: y equals x squared plus 3. And we got to decide, is that a function or not? It's not in function notation. It's just in y equals something with an x. So here we relate x and y. So it fits that description of a relation. So we know that it's relating x and y. We don't have a z in there. Something weird like that. How can we tell if this is a function or not? What do we know about equations? What can we do with them? We can do what? We can graph them, right? In Algebra 2, we worked a lot with polynomials and things like that. This is a polynomial. It's a quadratic polynomial. So we know, what shape does it make? Not a line. Like a U shape. Parabola is what it's called. So it makes a parabola shape. So question is, does it pass the vertical line test when we make that shape? So we can graph that. I'm going to use the graphing calculator here to show that graph, and I'm going to also draw it by hand there. So y equals, make sure you don't have any stat plots turned on. If any of these are blacked in, then you're going to turn those off by just pressing up arrow. And like if that one's blacked in, I need it to be turned off. So I'm going to press the up arrow, highlight it, and press enter, and it'll turn it off. And then we want to graph that, x squared plus 3. And hit graph. If you're not seeing the same window, if you'll hit zoom 6, that will set your window to the 10 by 10 window, which is the normal window. Would that graph pass the vertical line test? Yeah, absolutely it would. But that graph passes the vertical line test. If we were going to have to graph it by hand, you could do that. What's an important point on a parabola? The vertex. We can find that by negative b over 2a. Plug that in, get the vertex is 0, 3. X-intercepts are also important. Does this one have x-intercepts? No. So the vertex is at 3. How else could we get ordered pairs so that we get a good picture of the graph? pick some x values, right? Plug them in. So if I picked 1, 1 squared is easy. That's 1 plus 3 is 4. So I would have a ordered pair at 1, 4, and I would also have one at -1, 4. And I could do +2 and -2. 4 plus 3 is 7, so that's going to be somewhere up here. So we know it gets this shape in general, and that passes the vertical line test. So graphing calculator, we get a quicker and probably a better picture of it. So we're going to use that to help us a lot. But we can also still graph these things by hand and understand that we can build a graph by just picking x values and working it out. So that never goes away, that we can do that. So yes, this is a function because it passes the vertical line test. Right. One a little bit more difficult. Y squared equals x squared minus 4. Are we relating x to y? There's an x and a y in there, right? So, yeah, I would say we're relating x to y. Can we graph that? Yeah. To graph it with the calculator, can we graph a y squared? No, we got to have what by itself? Y. How do you get y by itself? Take the square root of both sides. So if I take the square root of both sides, I've got to remember plus or minus is in front of that. So I've got y is equal to positive and negative square root of x squared minus 4. Okay. So when I graph this with the graphing calculator, I've got to graph the positive side and the negative side separately. So I would graph square root of x squared minus 4. And then on the y2, I would graph negative square root of x squared minus 4. And then I've got to remember that that makes one graph. It's actually one equation that we're dealing with there. Huh. Does that pass the vertical line test? No. Now, is that a little bit more complicated picture than what we're used to? Yes, but it fails the vertical line test, so this is not a function. Could we build that graph using ordered pairs? Yeah, it would be a little bit more complicated and a little tougher to do because you got more stuff to deal with. You got to plug into the positive side and to the negative side. So you have plus or minus on all of those ordered pairs out of that. So graph, if you've got an equation, the easiest thing to do is get y by itself and graph it and check with a vertical line test. That's really what I would like for you to be able to do as far as that goes. Okay, so testing whether a relation is a function, x's can't repeat. Got to pass the vertical line test. If we're a graph, if we're an equation, we're going to graph it and check the vertical line test. Always got to keep in mind that we're relating x to y is the functions that we're dealing with here. All right, so once we determine if something is function, that opens up the idea of function notation. Function notation, f of x, remember, it's just the same thing as y. F parentheses x, f of x is the same thing as y. So when we're dealing with this function, f of x is equal to 3x plus 5. We'll start easy. And they ask us to find f of negative 5. What does that mean we should do? Yep. F of negative 5 means plug negative 5 in for x. And work it out. 3 times negative 5 be negative 15. Plus 5 is negative 10. Right? What does that generate? What is the -5 and the -10? What does that even mean? What are they? X and Y values. So that creates a what? Ordered pair. That's what function notation does. It shows us that in this function, the ordered pair, when x is 5, that function gives us, or x is -5, that function gives us -10 as the y value. That's what function notation does. It's a more descriptive way of writing y. So this is y is -10 when x is -5, as opposed to us just saying y equals -10 and having no description of what x was in that. So we get an ordered pair out of that. All right, let's go to maybe a little bit better function, a little more fun anyway. 2x squared minus 3x. And they want us to find f of 2x. Fancy. What's that mean we're doing? Yeah, just plugging 2x in for x and doing a little bit of algebra. 2 parentheses 2x squared minus 3 parentheses 2x. I always use parentheses when I plug these things in. That's a good habit to get into. You don't. Sometimes you kind of forget some of the exponent rules that happen. So be careful of that. So plugging that in, what happens first when we try to simplify this? It's the first thing that should happen. Exponents, parentheses, exponents, multiplication, division, addition, subtraction. You know, that whole order of operations thing's got to play by those rules. So 2x is squared. So what does that turn into? 4x squared times 2. And then I'm going to go ahead and multiply 3 times 2x, which is 6x. And then we've got to double that. So that's going to be 8x squared minus 6x. So a little bit of algebra to go along with some of the arithmetic we've been doing. Just to get your brain going into some algebra world. Fun stuff. Let's take the same function, 2x squared minus 3x, and let's find f of -x. That's an important thing as we progress through the course. There's some tests that we'll do that involve plugging in a -x. So practice doing that. So what's that mean we're doing? Plugging -x in the place of x and working it out to simplify. So that negative in front of the x is like a -1, so we just treat it that way and do the math the way it's supposed to be done. When I square -x, what do I get? X squared, so that's 2x squared. And then -3 times -x is positive 3x. We get that new function for f of -x this time. Where we can sometimes get a little confused, it's one of the simpler problems, but it seems to cause issues in classes from time to time. So let's take the same function, just be boring here. Does all the things I want it to do. Let's find negative f of x, which looks a lot like the same problem, but it's very different. What does that even mean? Don't overthink it. It's like -y. It's like -1 times f of x. And if I multiply the whole function by -1, what's it going to do? Change it to the opposite signs on everything, right? So -1 or negative f of x is taking -1 and multiplying it times 2x squared minus 3x. That's really what's happening here. If there were a 4 out here, it'd just be taking 4 times the whole function. If there were a 17 out there, you'd be multiplying the whole function by 17. So it's just multiplying by whatever's in front there and distributing that across to give us negative 2x squared plus 3x. But for whatever reason, that one tends to hiccup on a lot of folks in the past. Okay. All right, let's do a little algebra 1 here. Same function, f of x is equal to 2x squared minus 3x. We want to find f of x plus 2. So same game, just a little different take on it. What are we doing with the x plus 2? Plugging it in for x. So f of x plus 2 is equal to 2 parentheses x plus 2 squared minus 3 parentheses x plus 2. What is x plus 2 squared? No. No on that. Closer, but still not right. What does it mean to square x plus 2? It means x plus 2 times x plus 2, right? That's what that means, right? So then you multiply that out. X times x is x squared. X times 2 is 2x. And then we got another 2 times x, which is another 2x. So that'd be the 4x. All right, in the middle. And then 2 times 2 is 4. So we end up with 2 parentheses x squared plus 4x. Go ahead and do the simplifying. Plus 4. Minus 3x minus 6. And then we distribute the 2 across. 2x squared plus 8x plus 8 minus 3x minus 6. And what do we do from there? Like terms. So 2x squared plus 5x plus 2. Manipulated that function with an x plus 2. Now that. Be careful of that right there. Don't just square the x and square the 2. That's not correct. Be very careful of that. Very common mistake. So, all right. So finding function values is just exactly that. Nothing crazy different about that. Remember, it's an x value that turns into a y value. So what they're asking you to find, f of something, that something is the x value. They're asking you to find the y value out of that. Okay. Show you how to do function value with the TI-84. Say we had f of x is equal to 3x squared minus 5x plus 7. And we want to find f of 1.25. Something that wouldn't be, quick to do in our head. 1.25. We could all square it. We're not as fast at squaring 1.25 as we probably are at squaring 4. So it's not something that we would probably, this is not a higher level question. This is pretty low level on the taxonomy of questions. So it's just an arithmetic problem. So a lot of times arithmetic problems, we want to take a shortcut, and that's what I want to show you here. So to do that on the calculator, there's a couple of different ways. I'm going to show you both ways. One way would be to store that 1.25 as x. So you can do 1.25 and then hit this button right here, just above the on button is the STO, that's store. So we'll store that and then you pick what letter you want to store it into. I'm going to use X, which is right here beside the alpha, and then hit enter. And once you hit enter, it means every time you type an X on the regular calculator screen, it's going to read it as 1.25. And then I would type in the problem. I'd say 3x squared minus 5x plus 7. Hit enter, and it cranks out our value, 5.4375. That's one way to do it. Another way to do that, if you had to find several different x values for the same function, so like maybe you're making a table for some reason of values, the best way to do that is with the y equals menu. So clear out the other functions that we had been graphing, and I'm just going to type in the same function, 3x squared minus 5x plus 7. In the y equals menu, that x that I've typed there is not 1.25 anymore. It doesn't, they're like two separate parts of the building. Okay, it doesn't know that x is 1.25 on the regular calculator screen. It's just reading it as a variable. Okay, so once I've typed that in there, I can get those y values that I want for the x values by hitting second and graph. And you may have, your calculator may not be set where you can type in the values yet, so we're going to set that up for everybody, because I would rather type in my values than have the calculator generate them automatically, because then I control what's in happening. So to do that, we're going to hit second and then window, and you should end up at the table setup part of the menu, second and then window. You want your independent variable to be ask. So it doesn't matter what's here. That doesn't matter at all. You can leave whatever's there, minus 0 and 1. You want your independent variable, that's x, is your independent variable. You want it set to ask, and your dependent you want set to automatic. So it'll calculate. Okay. Independent to ask. So arrow down there. If yours was set to auto, you would arrow down and go over to ask, hit enter, and it's ready to use now. So then I would hit second graph. You may have some values already typed in there. You may not. I had some earlier. When I reset that, it took them out. Okay. Then I would type in the x value that I want to work with. I want to work with 1.25. There's that same y value. If I needed I usually only use this if I'm doing more than one x value. So if I needed to find 1.35, I could type that in there, and then I get a list of things. So I could type in several x values. So that's the easiest thing. If you had to make a table of values for some reason, this is one of the best ways to do that. So either way, it gets you the same answer. The only drawback to this is that if your decimal is longer, it's going to round it in this table. So that could be an issue depending on what we're doing. For most things, it's probably not going to be too much of an issue. Okay. All right. Now, let's get into the fun part. The domain of a function. All right. Big long definition in your textbook about domain of a function. It talks about it's the set of all x's that relate to a y value for the function and don't cause things that are undefined to happen in a function. What's an operation in math that's undefined that we've all encountered before? Divide by 0. That's the very first one that you ever encounter in math. Is you can't divide anything by 0 because you can't break something into 0 parts. Right? So if you have one thing and I want to break it into 0 parts, that's not possible without some lasers or some place where Star Wars-esque lightsaber of some sort. So you can't divide by 0. So that's an undefined operation. So when we're talking about the domain of a function, that's one of the things we've got to look for is division by 0. So when we're looking at a domain of a function, really kind of the best way to think about that is we're looking for the x values that work. So I'll put work in for a function. My handwriting will get better as this is the first day I've written anything by hand, I think, since Christmas break. So. Now, x values that work, what we're looking for when we're finding domain is we're really looking for the x values that don't work so that we can throw those away. Okay, so there are things that we start with. The domain for every function starts with all real numbers. And that's how we can notate that in set notation. It says x and then a straight up and down bar such that x, and this is the Greek letter epsilon, it's just like a lowercase c with a little line in the middle. That's how you make that. Just make a lowercase c and then put a little line in the middle. That means x is an element of the real numbers. That's the shorthand way of it. Instead of writing out all real numbers, we're going to write it this way. That'll save us a little bit of handwriting when we're doing some practice here. So x such that x is an element of the real numbers. It means all real numbers. That's set notation. There's another notation we're going to talk about. It's called interval notation. Interval notation, we're going from negative infinity to positive infinity. And we put parentheses on the ends. That's not an ordered pair. Okay? When we talk about intervals, we're talking about x values. When we're talking about domain, x values. It goes from negative infinity all the way up to positive infinity. So it means it's whatever numbers on the left is where you're starting. Whatever numbers on the right is where you're ending. Parentheses mean we don't include that number. And we can include infinities because we can never really get there. Once you think you're there, you go one more and you're not there anymore. But if it's a square bracket, and we'll see this as we kind of build some of this stuff, square brackets mean we include that number. So like if your function went all the way up to 3 and ended on 3, then you include 3 and you put a square bracket on it. We'll kind of pick this up as we go along here. So we're going to be doing things in set notation, that's this notation, and interval notation. So we're going to do both as we work through here, try to learn how to do that. Okay? Every function starts with that as the default. And then we start trying to look for red flags. Red flags tell us things are going wrong. Okay? One of the red flags that we look for is x is in the denominator. X is in the denominator. If there's an x in the denominator, what that creates is possibilities of division by 0. Okay. So that's the first red flag we look for. And I'll show you as we get to examples that have that, what we can do to that. The other red flag that we could look for would be square roots. I put in parentheses even roots as well. Square roots is the index of a 2, but you could do also fourth roots and all that stuff. We don't get too much into that. in this chapter. Later on, when we start dealing with logs and all that stuff again, there's some fourth roots and things that come involved with that. So even roots have the same rule as square roots. Odd roots do not, like a cube root doesn't have the same rules as a square root does. Okay. Now, so those are the only two red flags that we have to look for. If neither of those red flags comes up in the problem, then the domain stays negative infinity to positive infinity. Okay? Domain starts as negative infinity to positive infinity unless one of these red flags comes up, and I'm going to show you how to deal with those if they do come up. Okay? So let's start with some examples and start finding the domain. No idea what letter I'm on. O, I think. Here's our function. F of x is equal to x squared plus 5x minus 7. So there's our function. It's in function notation, so they're telling us it is a function. We don't have to test that. All we've got to do is find the domain of that. So right now, domain is negative infinity to positive infinity. Then we start looking for those red flags. Are there any x's in a denominator in this problem? No, not even any fractions in it, so they can't be an x in the denominator. So that red flag doesn't show up. Are there any square roots in this problem? There's a square root there? Where? There's a square. That's not a square root. So that red flag doesn't come up. So there are no red flags for this particular function. So that means the domain doesn't change. The only time the domain changes is if one of those red flags comes up. So because there are no red flags, so that's what we got to think here, no red flags. So the domain in set notation is x. X is an element of the real numbers. That's just a capital R with an extra bar on it, if you're wondering what that symbol is. It's just a capital R with an extra bar on the upright. That's the symbol for real numbers. That's set notation. Interval notation is from negative infinity to positive infinity. These both say the exact same things. Okay? We want to learn both forms. We use some interval notation for several things in here. So we need to start learning interval notation as we go here. So set notation is probably what you've dealt with in Algebra 1, 2, and geometry. We're going to start picking up that interval notation. All right. G of x is equal to 5x over x plus 3. So function, any red flags showing up? What? Which one? X in the denominator. We got that red flag right there with that X in the denominator. That tells us something's going on. Anytime there's an X in the denominator, what is the one thing that we can never divide by? 0. So what we've got to do is take that denominator and find out when is it equal to 0. So we take x plus 3 and set it equal to 0 and solve it. In Algebra 2, we call this restricted values sometimes, or restrictions on the domain. That's what we're finding here, are restricted values or excluded values. When we were doing rational equations, we called them excluded values. Same thing. So it's the exact same idea. So solve this, one easy move. That tells us x cannot be negative 3. That is the restriction, because if x is negative 3, what's negative 3 plus positive 3? 0. And what's the only thing we can't divide by? 0. So that's why we've got to find that. Okay. So our domain in set notation, that's the easy one, because you're more used to it. Not necessarily. It's all x's as long as x isn't negative 3. That's how you write the set notation for that. As long as x isn't -3. So x such that x does not equal, so an equal sign with a slash through it, -3. X does not equal -3. The interval notation, a little bit more difficult, okay? Remember, interval notation, it starts at -infinity and goes to +infinity. What we're doing is we're cutting a -3 out of it, okay? So one of the best ways to help you understand that is a number line. So when we got a number line, what's down here on the left with this arrow? It takes us toward what? -infinity. And up here on the right-hand arrow, it takes us toward +infinity, right? -3 is somewhere between there, right? What we're going to do is the domain originally was the entire line. So it starts at -infinity, and it keeps going until we get to -3. And -3 has been cut out. There's this empty spot. There's a hole right there where they've cut out the -3. So we've got to skip that. The way you skip that with interval notation is you write a 3 and put a parentheses there because that means you're not including the 3. Remember, or the -3, excuse me. -3 is what we're cutting out. Okay? But then we're picking up right after we jump over -3. We're going to start again and go all the way to +infinity. So we put -3 and then go to +infinity. So here's how the domain works. You're going along, -infinity, everything's good. Oh man, it drives so smooth. And then, oh, we got to jump over this pothole here. So we hop over that. That's where the parentheses, U parentheses. That's how you jump over a number. The U is a union in set notation. So jumping over that, and then we're picking up again right after we get over the -3, right? And then we're riding along smooth all the way to +infinity. So that's the interval notation for that. Okay. All right, let's look at another. H of x is equal to 12 over x squared minus 16. What red flag comes up? X in the denominator. So there's our red flag right there, that x is in the denominator. What do I have to do with that denominator now? Set it equal to 0. So x squared minus 16 equals 0. That's a quadratic. We know how to solve quadratics. I hope so. There are several ways to solve it. What's one way? Difference of squares, that's a great way. That's factoring. If we did that, it would be what? X plus 4, x minus 4. Good job. Then what do we do with those? Yeah, technically we're setting them equal to 0. We've done enough of these that you probably are doing that in your head at that point. So x equals -4 and x equals +4. We have two things that are restrictions on the domain here. What is another way to solve that besides factoring? Add 16s to both sides and get x squared equals 16 and then do what? Square root. Don't forget the plus or minus. If you're going to use square roots, you got to have the plus or minus. Those are two of the quickest ways to solve that one. What would be a third option? Quadratic formula. A little longer option for this one. I probably wouldn't do it that way, but it is an option. Negative b plus or minus radical b squared minus 4ac divided by 2a. All of those things still in play. Everything that you've done in a math class up to this point is in play. So either of those ways gets you the same answer. Quadratic formula gets you the same answer. So your choice on how you solve that. You got to solve it. All right. So now we have two restrictions on our domain. So that means there's two numbers that we got to leave out. The set notation for domain, that's the easy one. X, as long as x does not equal -4, comma, +4. The interval notation, a little more difficult, a little longer, but it's more descriptive than the set notation is. It tells us all of the x's that do work instead of just telling us the ones that don't. Okay. So the interval notation, we originally were taking -infinity all the way up to +infinity. We're cutting out -4 and +4. So our interval will start at -infinity. What's the first one that we're going to cut out when we're traveling up that number line? -4. So -4 parentheses u -4. We're back on the line. We're traveling along. What's the next thing? +4. We're going to have to cut it out. So there's where the 4 comes back. U parentheses 4. We're back on line. Where are we going next? That's the only other thing we're cutting out. So we're going to go on up to +infinity. Make my infinity a little bit better than that. So there's the interval notation for that one. Interval notation is going to take you a little bit to get the hang of it. Okay, I'm gonna be gracious the first few days with interval notation. That's one of the learning curves in college algebra, is learning that interval notation and getting used to reading that because they tend to use it a good bit in higher level math. If you go into calculus and things, set notation usually doesn't come up anymore. It's interval notation from here on out. Okay. All right, let's get another one here. Here's our function f of x is equal to the square root of 2x minus 6. What we got? Square root, red flag. Anytime it's a square root, it's a red flag. When we're taking square roots, what's the kind of numbers that give us problems? What kind of numbers give us problems in square roots? Imaginary numbers. That comes from taking the square root of what kind? Negative. So we need what's underneath the square root to be 0 or bigger, right? We can't have negatives in there. So because when we're talking about domain, imaginary numbers don't show up when we graph something on the xy plane, right? So we got to have 2x minus 6. It's got to be 0 or bigger. So what we do is we set whatever's inside of the square root that has the variable 2x minus 6. I'm going to set it greater than or equal to 0. And that locks that in to not being a negative number. When we solve this for x, it's going to tell us the x values that won't give us a negative number. So this one's kind of a little bit different than the division by 0 idea, because when we solve this, we're going to get our actual domain. We're not going to get the restrictions on our domain. So with the roots, it's a little different. So let's solve that. What do we do? Add 6. Simple algebra or 7th grade math here. Maybe 6th grade. I'm not sure. It's been a while since I was in the 6th grade. X's are greater than or equal to 3. That, in set notation, is our domain. In interval notation, this is where we got to use the brackets and parentheses and kind of think about this in terms of a number line. What's the first number that I start with that inequality? 3. It's the first number, right? So my interval notation is going to start with a 3. And is the 3 included? Yes, because I got an equal to mark right there. So because it's included, that's where I'm going to use a square bracket. That's the notation for, hey, 3 is where I start, but I'm counting it. It's part of the game, okay? Square bracket for that. And then I'm going up toward what? positive infinity. And I always use a parentheses on the infinities because you never can get there. That is the domain for that particular problem. Just a couple more. I know it's early in the semester and we're not used to enduring long lessons. But tomorrow you don't have to hear me talk at all. Here's our function. Square root of 8 minus 2x plus 7. What do we got? Got a square root. Does the plus 7 have anything to do with the restrictions on the domain? No, it's not inside of the square root. It's not in the division by 0 or anything like that. So that plus 7 is just, it's actually only affects the range. Doesn't have anything to do with the domain. So what am I going to do with the 8 minus 2x? Greater than or equal to 0. Good job. Okay. Solve that. Be careful. Why did my symbol flip? Divided by negative. Don't forget that little simple rule that can cause you to miss every one of them if you don't. If you divide by a negative or multiply by a negative when solving inequalities, you have to flip your symbol around. Okay. Domain then. Set notation, that's the easy one. I'll do that one. You guys help me with the interval notation. What does that inequality say? All right, so anything that's less than or equal to 4. So where does that start? What's the lowest number? Negative infinity is smaller than 4. So negative infinity is where I'm going to start. And I always use a parentheses there. Going along the number line from negative infinity, we're going along and we come in contact with 4. What's happening at 4? You're stopping. Are we including 4? Yes. So we have a bracket on that 4. And those are the domain representation for that particular problem. Not crazy hard, but the interval notation is going to be a little different for you. You're just going to have to kind of pick up on it. The set notation, you guys will fly through that part. The interval notation will take a little bit of time. Let's do one more. The culmination of all our studying today. Say we had 3x over the square root of 5 minus 2/3 x plus 4. Oh my goodness. What part affects the domain? The denominator, because it has what in it? An x. And it's got a what else? Oh man. It's a double red flag, isn't it? Okay, so we got to think about what does that even mean? Okay, so what do we know about the square root? What does that tell us? That our numbers inside of the square root have to be greater than or equal to 0, right? They got to be positive. But because it's in the denominator, what can it not be? 0. So when we set this up, what kind of inequality do we set up? Just greater than. Yeah, good job. Just greater than 0. We dropped the equal to because that square root was in the denominator. If the square root is normal, like the last couple of equations that we did, then you got the equal to mark. Because it's in the denominator here, we've got to drop the equal to because the denominator can equal 0. Okay, let's solve it. What we do? Drag 5. Multiply by the reciprocal. Over 2. Flip your symbol. And do leave that as a fraction. Don't change it to a decimal. Or a mixed number. We're in college now. Set notation. Let me take care of that one. What's the interval notation?
Pardon the interruption, teachers. At this time, please go over with your classes procedures for an earthquake drill. In case of an earthquake, you will get under a desk, table, or heavy piece of furniture and wait for the all clear to evacuate the building. We will use the fire alarm to signal evacuation. Therefore, you should also go over your.
All right, let's get this done before they do that. All right.
We will make an announcement for the drill to begin.
What's the interval notation? This is the last one. We're done at the end of this. Okay. Sharknado. So negative infinity. 15 over 2. Bracket or parenthesis? Why not a bracket? Not included. Doesn't have the equal to mark, so we've got to use a parenthesis. So there is our domains for that one. Not hard. This is not difficult stuff. It's a lot of stuff. All right. Listen up real quick.